So far we've talked about central angles, we've talked about inscribed angles, and now we're going to talk about other angles. Now they're going to relate back to other things we've talked about. They're going to relate back to chords and tangents, and then one that we haven't talked a heck of a lot about, the secants. So not very descriptive, but we're going to learn about theorems, regarding other types of angles. Associated with circles. So this comes out of lesson 9.6. Okay. So the first one is Theorem 9.9. And it says the measure of an angle formed by two chords that intersect inside a circle is equal to half the sum of the measures of the intercepted arcs. So the measure of an angle formed by two chords that intersect inside a circle is equal to half the sum of the measures of the intercepted arcs. So we need a picture of this, because wow, that's kind of crazy sounding. So here's my circle, and what it's talking about is you have two chords. We'll call that chord AB, and we'll call this chord CD. Okay. So the measure of the angle formed, okay, now we have two sets of angles formed, but what they're referring to in particular is this angle. And by the way, the guy opposite him is a vertical angle, so he has the same measure. And it says that the measure of this angle, we'll call him angle 1, is going to be the half the sum of the measures of the intercepted arcs. So according to this theorem, the measure of angle 1 is equal to half the sum of the measure of arc AC. So again, he's being intercepted by that angle, he's being intercepted by that angle, okay? Because both of them have the same measure. Why? They're vertical angles. Plus the measure of arc DB, or BD, doesn't matter. So basically what we're doing is we're taking those two arcs and we're averaging them, and that tells us the measure of that angle. Why does that make sense? Because to the left, the angle equals 1. To the right, that angle equals 1. So it makes sense that the angle would be the average of those two arcs that are being cut off, okay? I do have a proof on this. So let's go through that. So I'm going to take that diagram, I'm going to add a little bit to it. So this is AB, CD. I'm going to put some, this will be your angle 1, and then I'm going to add an auxiliary line. And then we're going to create two new angles, 2 and angle 3 in that upper corner. Okay. So our given is that we have chords segment AB and segment CD intersect inside a circle. Okay, so that's our given. And what we're trying to prove is that the measure of angle 1 is equal to 1/2 the sum of the measure of arc AC plus the measure of arc BD. Okay. So we need to draw statement and reason. We need to draw that auxiliary line AD. So we're going to draw chord AD. Do you guys see why we would draw that? Okay. Well, even more than that, what do the angles 2 and 3 have to do with our proof?
One is the exterior angle.
Okay. Okay. That'll come into play, but more importantly, that's great, we have stuff on angles, but how does that relate back to arcs? Yeah, but how does it relate to those two? Lauren? Yeah, so angle 2 intercepts arc AC, and angle 3 intercepts arc BD, which are the two that we need. So that's what we needed to do, is to create angles that would cut off arcs so that we can involve those arcs. But you guys are absolutely right. We are going to use that theorem from chapter 3 about the measure of an exterior angle is equal to the sum of the measures of the two remote interior angles. That's going to come into play here. Now, I just drew this from point A to point D, so postulate 6 through any 2 points. There is exactly one line. Works. Okay. And then let's put in that the measure of angle 1 equals the measure of angle 2 plus the measure of angle 3. And that would be the measure of an exterior angle of a triangle. And that's another reason why we had to create a triangle, is to use this theorem. Is equal to the sum of the measures of the two remote interior angles. Okay, and now let's bring in the information about angle 2 and angle 3. The measure of angle 2 is equal 1/2 of the measure of arc AC, and the measure of angle 3 is equal to 1/2 the measure of arc BD. And then the measure of an inscribed angle is equal to 1/2 the measure of the intercepted arc. Okay. And then let's see what else we have. Okay, so now I have the measure of angle 1 equals measure of angle 2 plus measure of angle 3. And I have a value for what the measure of angle 2 is. So I'm going to do a little substitution here. Measure of angle 1 is going to equal to, instead of writing measure of angle 2, I'm going to write 1/2 the measure of arc AC. And instead of saying measure of angle 3, I'm going to substitute in 1/2 the measure of arc. That's the lousiest D ever. That looks like BB. 1/2 the measure, oops, forgot the M. Measure of arc BD. So that's just substitution. Property of equality. And the only other thing I need to do now is use that algebra or distributive property and factor out the 1/2. So remember what we talked about with that term algebra? We only use that if we're only doing math on one side of the equation. If we're doing the same math on both sides, then that's a property of equality. But when we're only doing math on one side, then it's going to be distributive property is done on one side, or that's when the book will use algebra. But almost every single time they say algebra, it is the distributive property. So that was us factoring. And then we got what we needed. Okay. So that's that theorem. All right, so here comes the next one with a little spoken about secants. So we're going to add them into their own theorem. Everybody good? So this is theorem 910. And this one's kind of long. The measure of an angle formed by two secants two tangents or a secant and a tangent drawn from a point outside a circle I have the hardest time writing circle clearly is equal to, and here comes the hard part, 1/2 the, and I'm going to yell at you for a little bit, difference. Oops. So everything else we've had sums, and now we get difference. Of the measures of the intercepted arcs. Okay. So basically how I keep straight when do I add and when do I subtract is if I think about when I cross inside the circle, if I tilt it, it's a plus sign. That's the one thing that helps me remember the difference between 9-9 and 9-10. Okay? So when I cross, tilt it, it looks like a demented addition sign. Okay? So that's when I'm going to add, when they're inside the circle. Now, secant, remember, contains a chord. A tangent is perpendicular at one point. So let's go through all three cases. So case 1. We're going to do two secants from a point outside the circle. So we've got, this is arc X, and this would be arc Y, and we're going to call this angle 1. So according to this, it says the measure of angle 1 is equal to 1/2 the difference of the arcs. Does it matter the order that I write them? Yes, I have to put bigger, take away smaller, otherwise I'm going to get a negative measurement. So larger arc minus smaller arc. So that's how this one looks. The next case was two tangents from a point outside. So this is angle 2, and again, the inside is arc Y and the outside is arc X. So according to this one, it says the measure of angle 2 is going to be equal to 1/2 the quantity X minus Y. And then we've got the combination one. Right? Circle's getting smaller. So we have a point outside. We're going to have a secant, and we're going to have a tangent. So this is angle 3. Again, here's X is the larger one, Y is the smaller one. Measure of angle 3 equals 1/2 the difference, big arc minus small arc. So that's what this guy talks about. Okay? So generally speaking, if you haven't noticed it, it seems like the longer the theorem, the less likely it's in a proof, but the more likely it is in number crunching problems. Okay, and that's precisely what we're going to work on right now, is using both the theorems in some examples. Okay, so is everybody good? Okay. Normally a student needs to ask permission unless they're going to throw up. So hopefully he's not doing that. So example, find the measures of angle 1 and angle 2. Okay. So we've got a circle, and we've got a whole bunch of stuff. So this is A, here's B, here's C. D is right here where that secant intersects, and then we've got E and we've got F. And then we're going to give you some pieces of information. We're going to tell you this arc CE measures 70 degrees. This is angle 1. Angle 2 is coming out of A. This arc BD equals 26, and arc DF equals 50. Now, I'm not putting in the degree symbols, but remember they are there. Okay, so looking at this, we have enough information to solve both of them using both theorems. Okay, so Theorem 9.9 says, if I have two chords that intersect inside a circle, so we're looking at chord CF and chord DE, the angle that's formed, which would be angle 1, is going to be half the sum of the intercepted arcs. So that's going to be half of arc CE and half of arc DF. So again, this allows me to conclude that the measure of angle 1 is going to be equal to 1/2 of the measure of arc CE arc plus the measure of arc DF. Okay. So we plug in what we know. We have measure of angle 1 is equal to 1/2, and then inside the parentheses we actually have the values. So we have a 70 plus a 50. So that gives us the measure of angle 1 is equal to 1/2 of 120, and we get the measure of angle 1 equals 60 degrees. Okay? So that's first. Now we can use Theorem 9.10 because we've got two secants. We've got secant AC and we've got secant AE. So that says that the angle that is formed from those two secants, which would be the measure of angle 2, is going to be 1/2 the difference of the intercepted arc. So I have to go with the larger arc, which is the one farther away, arc CE, and I'm going to subtract from it the closer arc to that angle 2 would be the measure of arc BD. So we get the measure of angle 2 is equal to 1/2, and then inside of this parentheses we've got the difference of 70 minus 26. So we get the measure of angle 2 equals 1/2 of 44. And we get the measure of angle 2 equals 22 degrees. So both theorems in play in one problem. So that kind of gives you a hint of what your problems are going to look like. And you're probably thinking, thank goodness I have a week to look at this. Okay. Last one. This example is going to ask us to, they're going to tell us something. Segment BA is a tangent. Find the measure of arc BD and the measure of arc BC. So we're going to get a picture here. Here's B, here's A. We have a secant, AD. We have an arc, BE, and then point C is right here where AD intersects the circle. And then they tell me this angle is 100 degrees. This angle out of A is 40 degrees. This arc, CE, is 66 degrees. So, again, what I have is two scenarios. I have Theorem 9.9 and I have Theorem 9.10 being played out. So let's look at Theorem 9.9. And it says the measure of an angle that's created when you have two intersecting chords inside a circle is equal to half the sum of the intercepting arcs. So that's the measure of arc BD plus the measure of arc CE. So we get 100 is equal to 1/2 the measure of arc BD, which is the one we're solving for, plus the 66. So I'm going to multiply both sides by 2 to get rid of that. I'm going to use symmetric property. Measure of arc BD plus 66 equals 200. Subtract 66 from both sides, and we get the measure of arc BD is going to be equal to, not angle, measure of arc is going to be equal to 134 degrees. Now I move into a tangent and a secant, and it's saying that the measure out of angle A, which is at 40 degrees, is going to be equal to 1/2 the difference of the intercepted arcs. So the larger intercepted arc is BD. The smaller intercepted arc is the measure of arc BC. So I've got 40, I get 1/2, and I now know 134 for the measure of arc BD. And then I start solving. So again, I'm going to do the same thing. I'm going to multiply both sides by 2, use the symmetric property, and I get 134 minus the measure of arc BC is equal to 80. I'm going to subtract 134 from both sides. So I'm going to put it up here, do the math a little bit more easily. And I get the negative of the measure of arc BC is equal to, what is that, negative 54. And then I just divide both sides by -1. So I get the measure of arc BC is equal to 54 degrees. And there's my second. So both of those theorems being used to solve problems. And that's it.